Hello guys, this is Awnish from Developers and Coders Club. So today we are gonna try the problem Alice Potter and Dumbledore Army of the CodeChef Cook-Off 144B. In this problem, we are given the problem statement as the Dumbledore's army consists of n members. Alice Potter is planning to hold M Dumbledore's army sessions where the members will perform training tasks to improve their skill in defense against the dark arts. Initially, each member of the army has no tasks. Before the IS training session, Alice gives the PI participant a task that he can complete in TI seconds. And each subsequent session, Alice will add more and more difficult tasks. That is, TI is less than equal to TI plus 1. Let's assume that by the ith session, the jth participant has accumulated CJ tasks. Alice knows that sometimes there is not enough time to complete all the tasks in a single session. So instead of forcing them to complete all C1 plus C2 plus so on and so forth Cn tasks, she can allow them to complete only a certain number K of them. In this case, each participant can choose a subset of their tasks. In total, they have to choose K tasks and perform only those tasks. Each participant performs his task sequentially and spends time equal to the sum of the times of its task. However, different participants can perform tasks in parallel, so the total time of the session is equal to the maximum of the times of each participant. We denote the minimum possible value of this time by answer I, k. In order to optimally train participants for each session I, Alice needs to know the value of answer subscript I, 1 plus answer subscript I, 2 plus so on and so forth. Help Alice calculate these sums for her. So that was the problem statement. I know it is a bit long, but we will try to catch it via the sample test cases. First, let us check the input format. So first we are given two integers, which are nothing but n and m, which denotes the number of members of Dumbledore's army and the numbers of classes or sessions that are going to head. Then the I next lines, the ith of the next m lines contain two integers pi and ti, the participant who will receive the next task and the amount of time it will take to complete it for that participant. So that was the input format for us. Now constraints lies between n comma m lies between 10 to raised to the power 6. Now pi lies between 1 to n obviously. Ti also lies between 1 to 10 to the power 6. And as stated above, t1 is less equal to t2 is less equal to so on and so forth till tm. Now what we are given, let us try to analyze it. First we are given the number of participants they are in total, that is 5 in this test cases. Next we are given how many sessions they are going to hold. So it is 12 in this cases. That is the reason why 12 more lines are written in here. That denotes about detailings about the session. The first integer 5 denotes which participant will get the task, and the second integer denotes how much time he or she will take to complete it. So what is happening here? Let us try to understand it. In this test case, the first integer 5 and 1, let us try to do it. The first integer 5 tells us that 5 currently has only one task which will take 1 second to complete. So that's why we print the sum as 1. Now in the next session what will happen? Third participant will get a task that will take 2 seconds to complete. So in that case the sum will raise to 1 plus 2 equals to 3. Now in the third session the fifth participant will again get a task that will take 2 seconds to complete. Okay, so the next task he get is of 2 seconds. So what happens now? The total time to complete these tasks of these 3 sessions would be, to complete the first one it would be 1 second, to complete the second session's task it would be 2 seconds, that is 3 in total, and to complete the third session task 5 has to do both 1 and 2. So this is the crux of this question, that for every session the participant which will get the new task we have to calculate how much total time he needs to complete all the tasks he has been assigned till now. Okay, so by now we just got 1 and 3, but in the third session, as the fifth candidate gets a task which takes 2 time, we will not just add 2 to 3, we will add 2 plus 1, that is 3 to 3, and that's why we'll get the sum as 6. Now what will happen as the fourth session starts? The first candidate will get a task that takes 2 seconds. So there we go, we add 2 to 6 and we get 8. Now what will happen next? The fourth candidate gets a task which takes 3 seconds. So we just add 3 to 8, which gives us 11. But what now? In the next session, the fourth candidate again gets a task that takes 3 seconds to complete. So in that case, what will happen? We won't just add 3 to 11. We will add the total time taken by 4 to complete it. So what would that be? It would be 3 plus 3, 6. So we would add 11. We would add 6 to 11 to get 17. So this is how we are trying to get all the test cases. Now let us check it further as well for verification purposes, that whether our logic that we have built it so far is correct or not. So what would happen in another session? Again, the fourth candidate would get a task that will take 3 seconds to complete. So again, we will mention it here. So what's the total thing we are going to add now? It would be 3 plus 3 plus 3, 9. So 17 plus 9 gives us 26. Now the fifth participant gets the task which of 3 seconds. So we will add 3 and it would give us 3 plus 2, 5 plus 1, 6. That is 32. What next? The first candidate gets a task that takes 5 seconds. We will add it here again. And that would give us an addition of 7. So 32 plus 7 gives us 39. Next, the third candidate would get a task of 5 seconds. So that will give us an again addition of 7 to 39. So that would yield 46. Further, the first candidate would get another task which will take 8 seconds. So again, we will put 8 in here. And the sum will yield us 8 plus 5, 13 plus 2, 15 plus 46, that is 61. And finally, the second candidate will get a task taking 10 seconds in the final last 12th session. That will give us finally 71. So this was our logic. So this was our logic, and now let us see how we are going to implement it. So what are we trying to do? For every case, we are just adding the total frequency of the participant we have just assigned the task to. Okay, like in every case what we did, like if we assigned some new task 3 to 5, we add to the sum we already had, we added all these 3, like 3 plus 2 plus 1, so 6. So what we have to do to implement our code? We have to calculate the frequency of all these students, and as we give a participant a new task, we will have to add the frequency to the sum variable. So we are gonna do this by using the map data structure. So this is my code. Like first we have included the header file bits stdc++.h. Then we are using namespace std. This is just part of some snippet I use, though it is not being used in this code much. It's just ll for long and el for endl. Next, what we did, we started int main. Then this is again important part. It is a snippet. It fastens your code actually. Then what we did, we declared two variables ll, m and c that determines these values 5 and 12 respectively. Then we declare another variable s that we initiated from 0, which will calculate the sum Then we take the input of M and C, which was this 5 and 12. Then we created our data structure, unordered map of LL comma LL, that is long long comma long long. We named it as MP. Now we iterated over this whole data, and what we did, we created two variables x and y, take the input in them, that is these things 5 and 1. And what we did is stored the frequency in a map. Like what we did, against 5 in the map, it would be something like this, 1 stored. Now again, when we'll come to 3 and 2, it would be like this. Again, when we'll go to 5 and 2, what would happen? It won't add a new item here. No, this won't be the case. What would happen? It would be added here. So it will become 3. So that's how this thing works. MP of x plus equals to y. Whatever is already there in the map, we add y to it. Now, finally what we did, we added it to the sum variable and then finally printed the sum. So this was the code, and you guys can see just a second. It is getting passed here, and I have during my contest I have already submitted this. It was an accepted solution, guys. You can see it from here. Thank you.